This video is going to be programming part 2 for the AR2 robot. This is for version 1.5 updates. Did some pretty significant updates that I wanted to go over. So first of all, the biggest thing is that I changed the how it records the positions up here in the panel. So in the previous version I recorded J1, 2, 3, 4, 5, and 6 their step counts, which is kind of meaningless. You know, you look in the panel up here, that doesn't really tell you anything. So I've converted everything over to Cartesian coordinates. So now when you program the robot, you're programming it in X, Y, Z, yaw, pitch, and roll orientations. So that's going to make a lot more things possible. That makes position offsets possible. Eventually that may, make it possible to run G code and things of that nature. So a couple things that come with that, if we look at this move and scroll to the end of it, there's a $F at the end. So previously I was, in the kinematics, I was cheating a little bit. So now that I'm just using the raw kinematics to calculate the position based on the XYZ, yaw, pitch, and roll, we get into something called configurations. Robots have to have configurations to track where they're at, because in certain conditions, for example, if you've watched my set of videos on robot kinematics, this will make more sense. But for the wrist, the math splits the robot up into two pieces. The wrist is 3 joints, and that's considered the spherical wrist, and they all center about the center of the wrist. And then the other 3 joints, joints 1, 2, and 3, they determine the Cartesian point in space that the robot is in. So as far as the X, Y, Z position of the robot, that is all determined by joints 1, 2, and 3. The yaw, pitch, and roll is all determined by axis 4, 5, and 6 for this wrist orientation. The problem is that the math is a little bit ambiguous, and we get into a situation called singularity, where the robot can't do the math. It doesn't know which way the wrist is. I could flip the wrist forward and then reach the same position with joints 4 and 6 rotated opposite each other, or I could flip the wrist the other way and then invert the positions for joints 4 and 6 and get to the same position. So mathematically, a wrist can always get to the same position 2 ways, and that creates a problem. So that's why at the end of each move you see this $F for flip or non-flip. Robots have a few of these singularities. The biggest and most, the one that's a pain in the butt is the wrist. The other one is the elbow, because the elbow back configuration means you can get to the same spot in 2 ways with the elbow back. I chose to not deal with elbow back. As you can see up here, for J3 I've limited my joint 3 to go from 1 degree to 141 degrees. I've never had a need in all my years of programming robots to flip the elbow backward. I mean, it's cool, it looks cool when robots can flip all around, but mathematically it just added a bunch of work that I didn't want to do, and I'm lazy. So I just did, the only configuration I'm dealing with is the wrist. So let's load a new program here, and we'll teach a new position. Let's see. So we have wrist flip. So now let's jog the wrist the other way. So now the wrist is on the other side, and we'll teach a position there. And we see now that it is $N for non-flip. So the reason I'm telling you about this, normally this would be kind of invisible to you, but where this becomes problematic is when you're jogging in XYZ, yaw, pitch, and roll. For example, if I have the wrist configured like this, and then I start jogging the Y direction, let's say that we go, wrong way, if we go backward, so once the wrist gets straight, you can see that the wrist is getting straight up and down. I'm getting into a point where the kinematics that control the XYZ, yaw, pitch, and roll, they don't know that this wrist config is going to change, and then your moves might start getting a little bit irregular, and then you'll have to recalibrate the robot. So I would caution you, when you get into positions where the wrist is straight and you're trying to jog an XYZ, that you be very careful in knowing where your wrist config is. And if you start to get into a dangerous point where the wrist is going straight, but you know that you want to keep moving, you're going to want to, manually force the wrist over and then continue. Wrong way again. And then continue moving in that direction once you flip the wrist and got the wrist in the right orientation. So with industrial robots that have servos on each axis, servo motors, they have encoder feedback. I don't have encoder feedback, so I don't have any sensors to look at to tell me the wrist is about to flip and make it easier. So that's one of the downsides to this scenario of having a open loop stepper motor robot. It's very low cost. I think it's a great design. It's been a great project, but it does have a couple downsides, and that's probably the biggest one right there. The next improvement that I've added that I want to talk about is this next row of buttons here. This is a new row of buttons. It has TX, TY, TZ, and so on. Those stand for tool. Those are for jogging according to the tool. So jogging an XYZ yaw, pitch, and roll, that's pretty self-explanatory. I think that makes sense. Jogging according to the tool means that I'm going to be jogging according to the gripper, wherever the gripper's pointed. So if I was to point the gripper up, for example, and then I was to jog the tool Z, which is this is probably going to be the most useful group of buttons for this function. If I press tool minus, the robot is going to move directly forward wherever the gripper is pointed. So that means I can dive the gripper straight into a situation. So if I'm to change the pitch of the gripper and then do that again to tool minus, it's going to go wherever the gripper's pointed. It doesn't really care where the gripper's pointed. If I was to point the gripper up and then do tool minus, it's going to go up the direction that the gripper is going. And then again, TX and TY, those will go also follow the X and Y directions of the gripper. So in this case, you can see I'm moving that way. I'm moving the X direction of the gripper. And then in Y, you can see it's going to move straight along the Y axis. And if I rotate the gripper, let's use joint 6 to rotate the gripper a few degrees. Let's go the other way. So now I've got the gripper going a different direction, and now when I jog, you can see it's going to move in the direction of the gripper. So that's what these are for. The yaw, pitch, and roll of the gripper are probably not going to be much more useful than the yaw, pitch, and roll up here. I still have some future work to do with those buttons there, but that's that part of it. The next part of functionality that I've added is the travel track. Right up here there's buttons for the travel track, and it behaves pretty much like any other joint. You can see here in my moves, there's after the rotation, there's or the roll, there's a T for travel track. Right now it's at 40 millimeters. So it's the jog buttons are right here, and it still uses the robot speed. So if I have the robot at 15% speed and move the travel track, the robot's going to move back, and that's included in the moves here. So if I execute one of these moves that I taught earlier, let's do that. So we're back where we started. So those moves include wherever the travel track is setting, and I covered this in the calibration video, but just real quick here, for the travel track, here's where you calibrate it. You just put in the track length, the track number of steps. There's no limit switch on the track. It's manually calibrated, so you just have to manually drive the motor all the way to the end of its limit till it hits its hard stop and calibrate the track to 0. But I include that information in the calibration video. Another thing that I added was the entry field down here. I made some pretty good improvements to the entry field. So before there was no way to copy and paste or edit lines. So let me click in there and scroll back over. So obviously as before, you could use this for comments. I recommend using some hashtags and some lowercase letters, and then you can insert a comment right here like that. Now the improvements that I've added is that I can come get a position, let's say this position here. I can hit get selected and it's going to grab that entire line of code. I can edit the line of code and then reinsert it or replace the line of code. So for example, if I grab this and this 122 and the X was wrong, and I needed that to be 123, I could do that and then hit replace, and then up here now it's 123 and the X. So I can change and manipulate anything about my positions that I need to manipulate. The other thing is I put some brackets and a star here, and I've left that for comments. This also is lowercase, but if I wanted to, for example, call this my home position, I could do that and then hit replace. And now the move has a name to it, which is helpful. So not only can I add comments in my program, I can individually name each move, so it's easier to remember what that move was. And then if this move is something that I like and I want to use it elsewhere in my program, I've already got it here. I can just come down here and then hit insert, and it's going to copy that move wherever I want. I can just insert it as many places as I want, and that gives me the ability to copy and paste. And I can do that with anything. You could get a tab number and then paste that in, insert that, although you wouldn't want to tab number ones, that wouldn't work very well. But it makes some things a little bit easier as far as the navigation with the changes with get selected, insert, and replace functionality. So another change that I've made is register incrementation or decrementing. I've changed that to a double plus and double minus to increment a register. So just to go over that real quick, let me delete all that. So let's say, for example, that register 1, sorry, I'm in the wrong field there. Register 1, that I want it to equal a value of 5. So I can just click into my program, click that button, and when I execute that line of code, I come here to my registers. Register 1 is now equal to 5. And I can set that to anything I want. I could set that to be 15 if I want. So now when I execute that, I come back to registers, now it's a 15. So I can just statically set it to any number I want, but I can also increment it so that if my program is running in a loop, I can keep incrementing that number. But to do that, what I've changed is if I want to increment it by 5, I'm going to put in plus plus 5. And now, every time this line of code runs, this plus plus 5 is going to increment it by 5. So if I hit forward on that, we come in here, now it's 20. If I run it again, now it's 25, and so on, and it will just keep incrementing. Now if I was to change this to minus 5, get rid of that. So now it's going to subtract, and we go back down to 20. If I run it again, go to registers, now it's 15. So that was what I wanted to show you there, that incrementing and decrementing of registers has been changed from just a single minus to a double minus, or a single plus to a double plus. Okay, another thing that I added on the register tab, you notice I have these 16 these blocks of registers. Now what these are stored position registers. So each one of these is a stored position. So we've got stored position 1 through stored position 16, and you can use these anywhere in the program as much as you like. I have stored position 1 kind of set as default for Vision, but you can still use it anywhere you want. In this example, I'll just start at stored position number 2. But what this stored position does is it just holds information for offsets, or for positions that you want to call over and over. So each of these 6 fields we're going to call an element. So this is stored position 2, element 1, 2, 3, 4, 5, and 6. Within each one I can store an X position, a Y position, a Z position, a yaw, pitch, and a roll. So we have these to work with, and I'll show you how these work. If we come out here to the main program field, you'll notice here that we have a new button here that is a drop down that has some choices that wasn't there before, and we also have a stored position field that wasn't there before. So whatever you have selected in this list is what this teach new position button is going to do. So to use it the way that you used to use it, if I want to, just going to delete that for now. If I just want to teach a position like I normally would, let's say I want to move to the position I'm currently at 15 at these values, I just leave that at move J and just hit teach new position, and it works like it always has. Now let's say that this position over here that is going to be let's say that this is going to be a pickup position or a placement position for stacking parts or something along that lines. So let's say that I want to store these values in a stored position register so that I can utilize them later. I would come here and I'm going to use the bottom one called teach stored position, and I want to teach stored position number 2. Okay, so now that I'm on teach stored position and stored position number 2, I'm going to come in here, I'm going to put in a comment, and I'll just call that populate stored position 2. So I'll just insert comment so that I know what I'm doing. I'm incrementing it. And so now that that's selected and that's selected, I'm going to hit teach new position, and it's going to put lines of code in that say stored position 2 element 1 equals my current X, element 2 equals my current Y, element 3 equals my current Z, element 4, 5, and 6, and so on. Just put in all of my current positions in here. So the same values that are up here to the position I just taught, I'm now going to put them in a stored position. Now if we go here, they're not in here yet because I haven't executed the code. So this is a section of code I would put at the top of my program that only runs once and then get into my program loop later. So if I execute each of these lines here and then we go look at our registers, you can see now stored position 2 has all of those values in it. So now how we could use that is, for example, I could come in here and I could say move to stored position, and that also, all of these that are referencing stored positions are relative to this number here in this little field here. So if I change this to move to stored position number 2 and I teach that, it's going to say move to stored position number 2, and I can still give it a name. It's the travel track is a separate value. You can come in here and modify your track value as needed. Puts in all your speed values. So now if I was to execute that position, it's where I'm already at, but if I was to jog the robot away from there, let's move the robot away from there in a couple different directions, and then I execute this position, it's going to go right back to that same position. So that gives me a way to store this position in a stored position register, and then I can call it multiple times. I can call it multiple times at different speeds. For example, if I want to reuse this position elsewhere, I can do get selected, and then I can insert it anywhere I want in my program, and I can come in here and modify the speed if I need it to go to that same position at 100%. I could change it to 100%. If I needed the travel track to be at 100, I could do that. So that gives me the ability to take a stored position, throw it in some registers, and then call it anywhere in the program that I want. And then as far as stacking and whatnot, if we want to get into stacking, that gets a little bit trickier. So let me start over here and delete all this stuff. So right here at the beginning, we've identified our, we've defined our position. So now let's put in a tab. Let's see if I screw this up. Let's put in a tab. And now let's say that, well, before the tab, let's say that we're going to use position register element 3, or position register stored position 3 as our basis for offsetting. So I'm going to come in here and go stored position 3 element 1 equals 0, and I'm going to put that there, and I'm going to continue to do this for each element. I goofed that up, didn't I? I did it right. Just got them out of order a little bit, but it won't matter. So it's a good idea just to zero them out in case there's something else in your program. So we'll zero all these out. So stored position 3, all of its elements are zeroed out, and then the Z element, stored position 3 element 3 is our stacking offset. So I'm going to come here, and let's say we're doing a pickup and I want to come in above my pickup position first. So I'm going to come in here and say stored position 3 element 3 equals 100. So I'm going to be 100 millimeters up off the deck. So if I execute that position, come in here, stored position 3 is 100 millimeters up higher. And now if I come back to my main position here, and I want to teach the offset of a stored position, so I want to teach the offset of stored position 2 is where my main position is stored, and if I teach that, it's going to say offset stored position number 2 by the value that's in stored position 3, so it automatically just picks up the next stored position. So if I had a 3 in here, it would pick 4. If I had 4, it would pick 5. If you want to offset by some other one, you'd bring it in here and then just manually manipulate the number, which one you want to offset it by. But basically what this line says is that it's going to take whatever's here in position in stored position 2, and it's going to offset it by whatever's in 3. So what I'm expecting here is when I execute this row, it's going to go to this position but 100 millimeters above it. So let's execute it and see if that worked. Okay, so it came up 100 millimeters. So this would be a good way for me to teach an approach position. I could put in stored position 3 element 3 equals 100, and then I could actually go to the position. So then I could take this line, I could insert it down here, except I would change it to 0 now. So, and then this, get that, insert it below. So we start out 100 above, go to the position, change the offset to 0, and go to the position. So, and then I could set my gripper and pick up the part, and then I could again take this, insert that below there, get this, insert that below there, so then set my gripper, pick up the part, then I could set my offset back to 100 and bring my part up off the deck. And I can use this same methodology for stacking. You can set this up so that it runs in a loop, so that every time it runs the loop, it increments the stack height. For stacking, you could do rows, columns, and use offsets any way you want. I also have offset J, which would probably be a little less common, but if I wanted to offset a position, for example, let's see here, do offset J by position register 2. That's basically kind of a one-time use. It's not going to be as valuable, but if I put that in there, it's going to take whatever's out here in the XYZ yaw, pitch, and roll and offset it by whatever's in stored position number 2. So just another method for offsetting, but I would suggest probably pre-putting all your positions into a stored position before manipulating it. So the last thing to go over for the latest updates in 1.5, I just thought I would quickly walk through the blocks example that's in the Kickstarter video. Should be included here. You should just be able to type in stack blocks example. Nope, I misspelled it. If I knew how to spell, that might help. Okay, there it is. So here's the stack blocks example. So I thought I would just quickly walk through this real quick so that you understand what it's doing. I programmed a start position. This is where the robot starts out in the center of the screen before it starts picking up blocks. I start with the gripper open. I open the gripper. I define my pickup position. And so we go through and assign stored position 2 to these positions. Then I went ahead and defined my set down position. I jogged the robot down to the exact position I wanted to set the block. And then I zeroed out my pickup offset because I'm using stored position 3 as my means for changing my pickup position. And then I zeroed out my set down offset. I'm using stored position 5 to offset my set down position. And then my approach, I needed an approach for the set down position because I'm using these to increment the height every time I stack a block. I increment it by whatever it was, however many millimeters the block height was. But then the approach coming up above that entire stack, I chose to use stored position element 6 for that. And then I zero out my block count, so I'm using register 1 to count my blocks. So then we get into the main loop. Tab number 1 starts the loop. Immediately, the first thing I do is check to see if we're done. So every time this loop is running in a circle, if it comes back to the top and it says if register 1 is equal to 4, because I had 4 blocks, then jump to tab 99 and we're done, and it would come down here to the end to tab 99 to end of program, then move to this safe position. So that's how we get out of our loop. We always get out of the loop right at the beginning of it. So move to pickup position. So stored position 3 element 3 equals 200, so that's 200 millimeters above the block. So then I'm going to move offset stored position 2 by that 200 millimeters above the block. Then I'm going to set that stored position to 50 millimeters, and I'll move down to it a little bit slower because I'm hauling ass over to it at 100. Then I'm going to come down a little bit at 50. Then I'm going to move to the actual pickup position. So stored position 3 equals 0. Then I move offset stored position 2, offset by 3, which is now 0. So that moves me right to the pickup position. I close the gripper, turn the output on, wait for 0.3 seconds. And then we're going to pick up the part. So then I change element stored position 3 element 3 to 50 again, and I come up off of it. Then I set it to 200 and I come up faster, and then I move. What am I doing here? Yeah, sorry, that's where I'm moving faster. And now I want to start incrementing for my next pickup. So my next pickup, those blocks were 50 millimeters wide. So stored position 3 element 1 for the X, I decrement that by minus 50. So every time this loop runs, I'm going to move to the next block. It's going to go 50 millimeters forward, and then the next time it runs 50 more millimeters. So every time I pick up a block, it's going to move 50 millimeters. Okay, so now we're going to move to the set down position. Stored position element 6 is element 3 is 100, and it'll just stay statically at 100, so I'm always 100 millimeters above that stack. So when I move to offset SP4, offset of SP6, that's going to move me above my stack. Then I'm going to move to set down. I'm going to move SP4 offset SP5, and that's my first piece. So SP5, we haven't done anything with it, it's still 0, so that's going to go all the way down to the table. I'm going to open the gripper. Wait 0.3. I'm sorry, I'm going to wait 0.3. I'm going to open the gripper, and then we're going to move above the position. So we go SP4 offset SP6, which is SP6 is just the major approach above the stack. So that gets me, takes me really high off the stack. But now I want to increment the stack height because those blocks are 15 millimeters tall. So I take stored position 4 element 3 and I increment it by 15 millimeters. So the next time that I come through this loop, I'm going to be 15 millimeters taller than I was the last time. And so then I increment the block count, register 1 equals double plus 1, and then I jump to the beginning of the loop. It comes back up here to the beginning and it does it all again. It picks up another block. It's already, offset the X position of the block here by 50, so when I come to get it, I'm going to get the next block. And then when I take it over to set it down, it's already incremented the height by 15, so it's going to set down the next height up. So this program here, I'll leave this in here as a good example for you on using the stored positions and stored position offsets. I think that's everything from a programming side for the latest updates for version 1.5. So that's all I got. Thanks for watching.